Greetings everybody. Myself Palkumar Pathak. Welcome to LeetCode problem solving series. Today we are going to solve today's daily question, which is 2144 minimum cost of buying candies with discount. We will start by understanding our problem properly and then directly move to the most optimized solution because the question is much easier and simpler today. So let's just start by understanding what our problem is trying to say. So we are given an array called cost, which is containing like number of integers in it. Okay, now let me explain you what our task is. Cost actually represents the cost that a candy represents. Okay, like it contains the number of candies which represents themselves as their own cost. Like the first candy represents its cost, which is 1. Like it costs us 1, we can say, unit. Similarly, there are a number of costs of a candy present inside the cost. And what our task is that we are given a condition that a seller of a shop which contains these candies sells it on a discount. Now what is that discount? The discount is that if we buy 2 candies, okay, then for every 2 candies we get a free candy of which the price is less than or equal to the combined price of the 2 candy that we have bought. Okay, as you can see here, that for every 2 candies sold, the shop gives a third candy for free, and the customer can choose any candy to take away for free as long as the cost of chosen candies, like the cost of the candy that we are going to take for free, is less than or equal to the minimum cost of the 2 candies bought. Okay, this way we just need to calculate that at the end of the code how much will it cost to us to buy each and every candy according to the discount. Okay, like we need to calculate the total cost that we will incur after buying each and every candy according to the discount. Okay, so this is our complete task. Let me give you an example so that you can have a better understanding. We will take our first test case, which is 1, 2 and 3. Now as you can see, we have 3 candies of which one contains the cost 1 unit, second and third contains its own units, which is 2 and 3. So obviously if we want to buy 2 candies and get 1 for free, what we need to do is we need to compulsorily buy these 2 candies. Why? Because if we take these 2, okay, then its total will not let us to buy this one. Why? Because it equals to 3, which is not according to our condition. So we need to take the 2 maximum candies, maximum cost, buy them by giving money, and then according to that discount we can take this one which is having the lowest amount for free. Okay, I hope you understood that we need to take 2 highest costing candies, and then according to that we can buy another candy, the third candy, for free, which is containing lower cost than both of these. Okay, this is our simple condition. So for this test case we need to give the amount of rupees which is equal to 5. Why? Because we are buying 2 plus 3, which is 5. Then we will get all of these 3 candies because we will get this candy for free, the one candy for free. So this is our complete problem. Now let's move to the optimized solution directly for solving the problem. So for the optimized solution, what we can do is that first of all, we know one thing, that according to the constraints that we are having, obviously we will be having more than 3 elements itself. But what if we are having, obviously we are going to have edge cases which contains less than 3 elements too. Okay, so for elements like 1, okay, we don't need it to pass through our code. Why? Because we know that obviously we need to buy that element, like we need to buy that candy. So for that edge case, first of all we will mention an if, that if our cost dot size is less than 1, then simply return that a cost of 0, because we know that yes, there will be one cost which we need to return at the end. So here it is mentioned that it can be 1, so that's why. So after that, for the main code, what we can do is that for the optimized solution is that first of all we know that for more elements than 3, we are having a simple logic clear in our mind. which is that for every group of three elements, like three candies or three cost, what we need to do is that for every group of three candies or three cost, take the two most costliest candies and ignore the third one, like the last one, which is less costlier than both the other candies in that particular group. Okay, so and like just add the cost of that both costlier candies and ignore the third one. And this simple process we need to repeat for each and every group of three candies, for which obviously we are going to use a simple for loop. And using that for loop, where we are going to just like for every group of three candies, we are going to take the two and ignore the third one. We will add the two costs for every group. We are going to add that two costs inside the answer named variable. So let's just have that answer variable, which will be returning at the end of the code. So now, as I mentioned, let's just use the for loop for, we can say, returning at the end the answer and adding every two costs for every group of three inside the answer. But before moving to that, let me give you like a clearance of an edge case which can come in near future while we are going to run the code, which is that, let's say, instead of this test case, we are having this type of test case where we are having four elements. So what will happen is that, as I mentioned the logic, that we are going to take every group of three elements and take the two most costliest, which will be for this one 3 and 4, and ignore the third one. But what will we be doing for this element, like the last one? Okay, for every we can say test case of cost, we are going to do the same process, but for every test case, obviously this last element will be cutted out for every test case, where like it can't be added inside the group of three. Why? Because we are just considering a group of three itself. Okay, so for that, like instead of mentioning the iterator I inside the for loop, we are going to like mention it, or we can say declare it in better language. Technically, we are going to declare it outside the loop. Why? I will be mentioning it just now. Okay, for now, let's just go for the code. I will mention it in detail while we are declaring it outside the code, like outside the for loop. So for like the like main logic, as I mentioned, of taking group of three candies and adding the two costs only, what we can do is that, obviously, as I mentioned, we will start from the group, the last group, okay, the costliest group, and then we are going to move till the end so that it can be more easier for us to calculate. So for taking the cost group and then move to the end one by one, what we need to do, obviously, in this test case, you can see that we are not having every element sorted from ascending to descending. So for solving that itself, first of all, let's just sort our cost array, which can help us in a more better way. Okay, so that we can easily iterate through the cost after its sorting. So cost.end, and after this sorting, we will simply start iterating from the last element and move to the first element. Okay, I equal to cost dot size minus 1, and I will be moving to the last element, and I minus minus. Now inside this, what we are going to do is that, as I mentioned, we will just take the current element, which will be cost of I. Okay, add that inside the answer. So answer plus equal to like this. Then we are going to again take the next element, like from descending to ascending way, next element, then the current one. So for accessing that and adding that inside the answer, we just need to do cost of I minus 1. So we will take, like we can access easily the next element, and then we will simply ignore the third element for moving to the next one. So for ignoring the third element and moving to the next one, okay, let me just show you what I'm trying to say. What we are doing, this is already sorted. Okay, so what we are doing inside this for loop is that we are taking this 4, okay, adding it inside answer. So answer equal to 4 now, because it was 0 at the start of the code. Then we will again add 3 inside this iteration itself. Okay, we are still at 4 itself according to the iterator. So we will add 3 also. So answer equal to 4 plus 3, 7. And we will ignore this. Okay, we are doing these 3 processes of adding the these two starting elements and ignoring this inside the current first iteration itself, the iterator, while the iterator is at the first element itself. So what about these two? Because we need to ignore them because the process that we need to do with both of these are already done while we are at this iterator, like this position, the first position. So for ignoring both of them, the 2 and 3 itself, instead of I minus minus, we are going to do I equal to I minus 3, which will help us to directly, after processing like these three elements, while starting iterating from this, as I mentioned, we just need to don't do anything with both of these and just move to the last element. So for doing that, we are going to use I equal to I minus 3, which will help us to move this pointer to this pointer minus 3. So 1, 2 and 3. So it will help us to directly move the pointer from this position, the first position, to this position. Okay, I hope you understood what I'm trying to say and why we did here I equal to I minus 3. So now what will happen is that this code will still give an error. Why? Because we have here written I greater than or equal to 0. So we are moving till the last element, and after reaching here, we are mentioning the code, the compiler, to access I minus 1, which is not existing, because at this last element there is no next last element. Okay, there is no I minus 1 for the 0, I equal to 0. So obviously it will give us an out of bounds error. So for like dealing with that, what we need to do is that we need to write here 1, so that we are just going to move till here, this element, and then we are letting it to access the last element by using I minus 1. Now obviously you would have figured out that it will again give us error. Why? Because then we are going to skip this element. How we can access the last element? So for accessing that, now comes the actual logic, that why I write iterator, like why I declared that outside the loop. It is because for writing this complete logic, and after writing that logic, obviously as I mentioned, we need to access this last element, the 1, the exact last element, which is going to be skipped if we are running this loop. So for accessing that, we just need to check that if our current I is equal to 0, okay, then we know that yes, we have reached our last element, and our last element is not a part of any group of 3. Why? Because if our last element, which is I equal to 0, would be a part of a group of 3, then if it is a part of a group of 3, then this loop itself will move the pointer to the next like iteration, then 0, which is minus 1. So I will be equal to minus 1 after the ending of this loop. So we know that yes, our current element that we are on, which is our first element, is a part of a group of 3. Then we know that yes, we don't need to do anything with that, and we just need to move to the like returning the answer. But if it is not a part of group of 3, then after the like I equal to I minus 3, the movement of the pointer from the last group, okay, before the first element, the pointer will move to the last element. And if it is at the last element, then we know that yes, it is not a part of any group of 3. And we know that yes, we also need to process it and add it as a cost to the answer also. So if I equal to 0, then add that cost inside the answer. So cost answer equal to cost of 0. Okay, I hope you understood completely why we did this complete part. Okay, so this way we are going to complete this whole logic for solving this complete problem, the main logic to solve the problem, the most optimized logic. And at the end of the code, obviously we are going to return our answer. So return answer. So this is our complete code to solve the problem. Let's just check it if that works for our main test cases or not by running the code. So let me just run the code. So yeah, it perfectly works. Now let's just submit the code if that works for our internal edge cases or not. So yeah, it perfectly works. Obviously due to like the place that I am currently on, the low network problem, obviously the engine is showing this much. Otherwise you can test the code. Okay, obviously I'm going to attach this complete optimized code inside my description of the video. Obviously you can see we are using a single for loop, which lets this code to become order of n, which is an optimized way to solve the problem. So this was the complete approach for solving the problem. If you like the way I mentioned and solve the problem, you can like the video. If you want to also check other videos like other questions, then you can check the LeetCode problem solving series. Again, I am trying to mention like daily question, daily to daily. So for following that along, you can subscribe to the channel. And if you want to connect with me personally, you can use the social connections link present also in the description of the video. So thank you very much for staying till the end. Thank you.